Thank you, Bill. First of all, I would like to thank all of you for coming here, and I'd also like to thank the organizers for giving us this great opportunity. We're excited to discuss our work on cumulative environmental impacts in Santa Clara County with all of you. And to start out, I would like to note that this is an interesting collaboration between, and Bill alluded to this, between the social sciences and the natural sciences, which encompass both in the Department of Environmental Studies and Sciences. And I would also like to recognize the many contributions that Will has brought as basically an equal partner to this work. And as Bill said, he's moving on to graduate school, and I'm sure he has great things ahead of him. Just a little bit of a roadmap here for our talk. We're going to trade off talking a bit. I'm going to start out introducing a little bit about how do we figure out if some people are disproportionately exposed to environmental hazards. What is our thinking behind that? What has been done before? Then Will is going to show you or walk you through our methods in a bit more detail. I'm going to discuss what our results to date. And then Chris, at the end, is going to put this discussion into the larger framework of environmental justice, and then leading us into a discussion, hopefully, with all of you. I'd also like, we will make time at the end for discussing this work, but if at any time, you feel that something is unclear, or, feel free to interrupt us as well. You probably know Silicon Valley better than I do, as probably a relative newcomer. It's a place of incredible diversity. There are many realities in Silicon Valley. We've gone through a rapid transition from a natural state to an agricultural valley of the Valley of the Heart's Delight to more recently this globally known place called Silicon Valley. And in the process, we've had a lot of developments, and now we're living with those consequences. They are a dense network of freeways and thoroughfares through neighborhoods and sprawling suburbia, often traffic that is hard to battle. We have one of the densest networks of Superfund sites, from the computer chip technology industry. And all of this development has, on the other hand, brought incredible riches to at least a segment of the population, as illustrated by this little cottage here in Los Altos. And then we are fortunate to have this incredible network of parks and open spaces that, because of our climate, are usable year-round. So this diversity in place is only matched by the diversity in people. We have a relatively small black population. The graphs here on both the pie chart and the bar chart have the same color coding. So the darker blue refer to white. This is census data that we plotted from the census tract scale. Red is Asian. The light green is Hispanic or Latino. This is all self-identification of the households. This is plotted by household. Then the lighter blue refer to Black and African American, and then orange is Native Hawaiian, Pacific Islander, and then we have a very light kind of grayish blue American Indian, Alaska Native. We see that by race or ethnicity in Santa Clara County, the majority of the population is pretty evenly split between Latino, Asian, and white, by self-identification. Now, if we plot this, the percent of households that self-identify belonging to a particular group, and then bin this by income, so there is percentage here on the Y chart and on the Y-axis, and then we have bins by income. The lowest one is 0 to 10,000, unimaginable that somebody can actually exist in that bracket, and then we have on the other end of the spectrum, 200,000 or more. And you can see that's a sizable population. So we see that we have a large segment of the population that make due between $0 and $50,000 per year per household. And disproportionately, those families are Hispanic or Latino or Black or African American. And then if we go to the other end of the spectrum, also a sizable segment, but here disproportionately represented are white and Asian households, right? So We have a place here in Santa Clara County that has diversity in space, in experiences, and a great diversity in economic resources and racial or ethnic backgrounds. So it's a prime area to ask questions like, where are the injustices, what populations are affected or benefit from certain environmental surroundings. The first thing that comes to mind in California when you talk about environmental hazards is, of course, the air. But in general, we've actually made some strides. We're plotting here the data from the California Air Resources Board for the county level, Santa Clara County. And we can see that both for ozone, average day above the standards, and for nitrous oxides, actually the values have gone down since the 1980s, a lot due to environmental regulations. Okay, and generally our air has become better, although we're still earning an F grade from the American Lung Association on the report card, right? So things are looking up, but there is definitely a lot to improve. At the same time, there's been a heightened awareness of all the exhaust that is coming from our very busy freeways and roadways and their effects on people. So the EPA has recognized something that they call mobile source air toxics that affect people near heavily trafficked roads. And it's been recognized to the point that a California Senate bill actually required the review of school sidings that are closer than 400 meters, which is about 1,200 feet, from high traffic roads because of the particles that are emitted. And the ones that are of particular concern near roads are these ultrafine particles, black carbon, carbon monoxide, and then the various nitrous oxides. Of course, we're also concerned about ozone, but ozone is something that spreads out further from freeways. It distributes more. It is not something that would be higher near roadways and then dropping off as we're going further away. There have been studies linking the emissions from roads to cardiopulmonary health effects. And also there have been many studies trying to measure how far from the roads you can see the elevated levels of these particulates of concern. And a commonly accepted range is 100 to 500 meters, which corresponds to 300 to 1,500 feet. Now, this does not. These are general generalizations. That does not mean that at any particular day you would be experiencing that. It does not take into effect, for example, wind direction or topography. So the question then is: do we all breathe the same air? As a representative of, are we all exposed to the same thing? So in many respects, yes, because a lot of these pollutants do spread out, and they don't make any distinction of whether you're earning $200,000 or $10,000 a year, and you're still traveling on those same freeways, or the ozone may be moving into Los Gatos even more than some of the areas that are closer to the bay and maybe not as economically strong. However, there have also been many studies that health outcomes are the result of the cumulative burdens that a person experiences. So it may not only be the traffic, but also your soil may be contaminated because you're living close to a hazardous waste site, or then maybe there's a dry cleaner across the street. Things like that. Everything that's coming together that's affecting your health. And there have also been more recent studies that show if you're already stressed, due to your economic situation, due to your social situation, then some of these pollutants may have greater effect on your health than if otherwise you have greater resources or greater security. So that is why people have started to ask, is there a disproportionately larger effect of these environmental burdens on certain populations rather than others? And one of this line of study goes back about 10 or 20 years. And the greatest focus, almost exclusively, actually has been on the Los Angeles region, another region of great economic and population diversity, and notorious for its bad air, right? So some of the early studies focused on certain populations more exposed to, these are some hazardous waste site locations than others. So here they're comparing those hazardous waste sites in Los Angeles, and they're represented by these dots here. Some are older, some are younger. And then the gray shadings represent neighborhoods where there has been like a change of ethnicity, very recent change of ethnicity. They call it ethnic churning. They're trying to get at the question is, are these waste sites cited in those minority areas? Or in California, the word minority, I guess, is mute. In the communities of colors, or is there move-in because these areas tend to be cheaper? So they're looking at one type of hazard, and then how does that relate to a particular segment of the population? Now, this work has been mainly taken on by a group of researchers at UC Berkeley in conjunction with different government agencies such as the California Air Resources Board and then also the EPA. And it has been continually moved forward to, let me just show you an example. Again, for LA, it has essentially just focused on Southern California from that same group. This is a 2011 paper. And they're looking now at a number of environmental impacts on different populations. They're looking on hazard proximity and land use. They're looking at air pollution exposure and health risk. And they're looking at social and health vulnerability. They're looking at all these factors together and how they affect different populations. Okay? So the question is, how do they do that? One, so they're basically developing what are called screening tools or cumulative environmental impact assessments. And they're making use of a technology that's called Geographic Information Systems, or GIS, that allows you, it's on one hand a mapping tool, and it also allows you to put several layers of information together. For example, information on the social vulnerability, as in terms of where populations that are economically disadvantaged, or where how do people predominantly self-identify in a particular census, and they overlay that with information on hazardous sites or air pollution or cancer risk for a particular census tract. So this GIS technology allows us to put these layers on top of each other, and then within GIS we can develop certain models or protocols that then are called, these screening tools are then called cumulative environmental impact assessments. So these account or try to account for all environmental hazards that affect a given area. So let's say we have a neighborhood over here. We're looking at where the toxic sites, where the Superfund sites, where the freeways maybe, and what's the overall cancer risk, and putting that all together. They can also account for the socioeconomic variation, and they look at the spatial distribution of the population, but then also of the environmental hazards. So these screening tools exist for mainly Southern California, and then the EPA is currently developing one on the national scale. However, that is at a scale where Santa Clara wouldn't be looked at on a neighborhood-to-neighborhood basis, but it's all it would take the whole San Francisco Bay Area as one region, and it would miss some of these neighborhood-to-neighborhood differences. And the other thing is, it's still under construction, and it's mainly meant for internal EPA use. So right now, before we started this work, nothing like that existed for Santa Clara County. Oh, and then the other thing is, none of these previous studies have really explicitly taken into account the effect of these mobile sources, of the freeways and the thoroughfares. They have tried to take larger model data, but they have not taken the actual freeway location and how that affects different neighborhoods into account. They have also not looked at, what is the discrepancy in access to environmental benefits. They have not looked at, this neighborhood here, there might be, toxic sites, but, there is a large park or a wetland, that may give people some respite from daily life, versus the neighborhood over here is, through cut by Freeway 280 on both sides. There's no walkability, and, on top of being exposed to all the emissions that are coming from that freeway. So what we have seen is that, one, there's not one of these screening tools available for Santa Clara County, and two, there are certain factors that so far have been left out from these screening tools that may be particularly relevant for Santa Clara County, because we have these, for one, wonderful parks and open spaces, but we also have this dense networks of freeways and thoroughfares, and then also we still have the agricultural part of the county where pesticides are emitted and there's pesticide drift that also have not been consistently been incorporated into these previous studies. So those are all additional factors that we're taking into account. And the question that we're trying to answer with this work then is, are there spatial patterns in Santa Clara County with respect to social vulnerability, like populations that are more vulnerable to these emissions? Is there, what's the spatial variability of the environmental burdens and the environmental benefits? And then how does the inclusion of these additional factors affect the outcome, affect the scores of our cumulative environmental impact assessment? Can we, once we do this analysis, once we put these layers on top of each other, can we recognize some environmental inequality in terms of proximities to environmental burdens or access to the benefits? And then how can we involve stakeholders to use this information to build healthier communities, right? To change the situation if there are inequalities. Okay, so any questions to the setup part? Yes?
On one of your early slides, I think it was the pollutants close to high traffic areas.
Yeah.
You listed the pollutants there, but didn't include CO2. Is there a reason for not including CO2?
It is not a... So CO2 is mainly a concern because of the greenhouse gases.
Right.
The ones that I'm listing here, and there are other emissions from tailpipes. Those are the emissions that are concerned if you're very close to the road and then drop off further away. So you would really benefit if you were further away from the freeway with respect to those pollutants. But there are others. There's ozone, there's CO2 that we have concerns about for other reasons. Okay? But very good question. Sorry, I wasn't clear on that. Yes?
What's a stakeholder?
What's a stakeholder? A stakeholder to me is a person that has an interest of in that particular work in that community to work for change. Chris may have a better definition.
Well, anybody who has a stake or interest in the outcome. So it could be your health is being impacted. It could be that you're where you live, or that you're concerned that you want to make some kind of change for other people's health, or the value of your house, or you're driving on the freeway. Anybody, to some extent, with air pollution, we are all stakeholders. It's impacting all of us in one way or the other. But some stakeholders it's going to have a bigger impact than others, right? So, yes, school, for example, school, you can see an organization can be a stakeholder in this process.
Okay, so let me pass the torch to Will here.
Thanks, Iris. So I'm going to go through the methods that we use to construct our cumulative environmental assessment and the indices that we put into that. This is just, we saw pretty pictures of Santa Clara earlier. This is just an overview of the county. The way we're doing all of our work is in census tracts, which split up the county by population give or take a little bit. So like 3,000, I don't know, like 9,000 people in a tract. So the cumulative environmental index is built up of three things for us. The one you saw earlier by Sad et al. It had the social vulnerability and the environmental burdens in it. The thing to note here is that we are adding an environmental benefits index that Iris mentioned a little bit. And where are the environmental benefits? The parks and the open spaces in this case. This is kind of a summary of the recent papers in this relatively small literature of cumulative environmental assessments. It goes back a little further than you see here, but this is kind of the main kind of meat of it. You can see as far as social vulnerability is concerned, everybody's using fairly similar factors. Ours are on the farthest left, and we've used essentially what we felt to be pretty much the consensus and what we also thought were good factors. Here they are, just kind of drawn out for you again. Maybe it's of importance to note that 200% of the federal poverty level is something that doesn't necessarily exist perfectly everywhere, so we've had to take what we could get and then base our calculations off of numbers for the poverty level in some places. This is a quick look at the same sort of data table for environmental burdens or hazards. This is, again, just what has been used in the past, and we tried to use everything that we could, but we do face some constraints. I mean, there aren't refineries in Santa Clara County, there aren't ports, there are airports, but also we didn't use this PM 2.5 and ozone data because there simply aren't enough monitoring stations in Santa Clara County, which is something that really hopefully will get fixed. This is the same kind of list, but again, the things we've added here, important to note, is freeways and highways. Those are things that were included in different ways in previous work that we're including specifically as features. Everything else, I mean, the range of kind of hazardous sites is pretty wide. Things like, hazardous wastewater and hazardous waste itself, different sorts of air pollution, Superfund sites, which are just, can be a Superfund site for a variety of reasons. And then last on the list is the National Air Toxics Assessment, which is one of those modeled data sets that comes out of the EPA, and we've used it for estimating cancer risk, which we then put in as a small part of our work. Yeah. It's another classification of, hazardous site. I can't remember the specific legislation.
Lower level contamination than a Superfund site.
So the number in this. I think this is still even a shortened list. There's a couple other types of. Various. These are all coming from the EPA. It's a variety of sites that are all.
With various levels.
Yeah. So here is just kind of a plain map of where all these things are. The various dots are the different types of sites or features that we're going to include in the ultimate index. The airports are purple. The toxic release inventory sites are blue. Which ones are which actually isn't terribly important, because the thing to note is that they're both spread kind of spatially, but also certain areas face a much higher density than others. You can also see both the freeways, the highways, and there's some railroads in Santa Clara County as well. The map in the background is the one of cancer risk, which comes from, again, the NATA data set. So this is a map of diesel particulate matter coming from the EPA. And we bring this up because this is what other people have used to kind of estimate the impacts of freeways. And if you look at it and you look at where the freeways are, they don't seem to make a whole ton of sense. The freeways have been there for a while. It's not like they've moved. So why doesn't the diesel particulate matter match up a little bit more accurately with what we see where our freeways are? So we have instead done this, essentially. This is the intersection of some freeways as well as some expressways and highways that all have been given buffers and then various weights going kind of inward to the highest. And the way we've kind of combined them is when when various freeways intersect and when these different roads kind of cross over each other, we're compiling these effects because that's what happens in reality. Yeah.
Two quick questions. The previous foil that you had, do you know how the EPA collected that data?
The diesel picket matter.
Yeah.
So that actually comes out of another just this large scale NATA model, and it part of the difficulty with the model is it's coming from 3 separate models that build it up, and it's coming from a host of data sources which aren't actually explicitly given. So
it was modeled data?
yeah, it's highly modeled data.
At a different scale.
Yeah, and it's also
And then because I was thinking you were just talking about the lack of fixed monitors.
Yeah, and I think that actually does play into it. Because I don't know where they're getting the data from if they aren't getting it from the very few monitoring stations we have.
Yeah, the other question was that previous map that you have. When you think about environmental impacts, maybe it was the previous one. I know are you thinking about the water quality or the water source or the climate change impact, or is that a separate?
We'd like to be, but at a certain point, and especially if you kind of look at the history of cumulative environmental assessments, you have to kind of draw a line somewhere. So it'd be possible, but it'd be terribly time consuming to try to go to each of these sites and give it a weight, and we'd still probably do it wrong. It's very hard to kind of arbitrarily assign the weights as it is. So trying to specify which one, what does slightly healthier or more polluted water mean to the people surrounding it? How far away is that going to impact them?
The other thing is, in terms of water, most of our water is imported. So that is actually then the environmental impact from further away that's distributed out, and not something that we can separate out neighborhood by neighborhood.
The other thing to keep in mind, and Chris is going to go over this a little more, is while we are worrying about the various health impacts or critical distances or what the scientific impact of this is, we're not actually trying to measure a cumulative impact on a person's health. We're not trying to measure this is how much you're going to get sick, because that's a really, really hard thing to measure. The health science is just coming out on how these different air pollution factors interact, and we're counting dozens of them all together. There's no way we could possibly have a good answer. So it's both a kind of relative measure and it's cumulative. So it's really only relevant when you're comparing it to itself across kind of space. Moving on, so this again is the combination of these freeway buffers, and when you zoom out, it looks something like this. So this is all those features buffered and combined. You can see where all the freeways and those hazardous sites are up on the top. Down here, these spaces you probably didn't see before is because they're big pesticides areas, which we just gave a single buffer. This kind of very simplistically is the way in which we've turned the map you just saw, which shows various kind of buffers and weights and all of that, into census tracts, because you need to turn it into something in a single map. So we've done it by kind of area and weight, because there's different kind of levels of weight and they're covering various amounts of census tracts. We've just multiplied it out. So something that covers half of a census tract with a weight of 0.5 would multiply out to a value of 0.25. So on and so forth, and we combine all those values by census tract. Lastly, the Environmental Benefits Index. So this is a new thing, so we've kind of compiled the data and chosen based on what we thought was a good choice to do. We've taken all the city parks and county parks and state parks, also open spaces and wildlife refuges, and we combine them in a similar method as the environmental hazards. And with that, I think I'm going to turn it over to the results from Iris.
Yeah.
I just wanted to ask first that you said is everything weighted equally? Essentially, if a point, if there's an airport, is weighted equally to their.
Yeah. So
Yeah.
for the most part, all those hazardous sites we did give similar weights, weights and buffer distances the same. We gave different weights to the freeways because we found there is a literature on, as Iris discussed, the critical distances from freeways. So those have separate weights.
So that is a major shortcoming and critique of these screening tools.
Yeah.
On the other hand, it is incredibly involved, and we don't have the measurements to actually do the physical modeling, like how many emissions are coming from a particular source, where do they travel over time, and how do they compound from other sources.
Yeah.
So the assumption here is that you're more affected the closer you are to a particular source, but we're weighting those sources equally, which is what has been done in those screening tools by the EPA as well. Yeah.
And then the other question, because you mentioned pesticide drift from agricultural areas,
Mm-hmm.
and you're expressing, say, city parks and so on as environmental benefits, which I wholeheartedly agree with, but what about the possibility that there are also environmental hazards associated with, for instance, pesticide use in city parks?
So the database that we used was a county database of registered pesticide application.
Permits, yeah.
Yeah, so I'm hoping that if they apply that they would have also registered the pesticides that they're using.
So hopefully they should be in the same spot, and they should be, well, not balancing out necessarily perfectly. I mean, in the cumulative idea.
So in the way the model, in the way it's so it's reverse index exactly. So the benefits are
the benefits are
positive
detractive,
and the burdens are negative. So they would, ideally you would see it basically. They would both affect the average cumulative score for the
Okay.
Yeah.
Okay. So if we now take all these different cumulative burdens and their effect as they spread out, with distance, and then we transpose them onto the census tract as our unit of analysis. We're using the census tract because for that we have population, right? And we're using this kind of weighted formula that we'll introduce there. Then as a result, we get the whole environmental burdens index. So this is a combination of all those hazards and then transposed onto the census tracts. And what we can see a spatial pattern emerging here, right? The values are going, and those are like relative indices. It doesn't mean a certain level of pollution. That we go from very low in mainly these outlying areas here to very, very high to areas where we have, dense network of freeways, as well as what we saw from Will was showing, a dense legacies of toxic sites and Superfund sites. And then along the 101 corridor and down to Gilroy, and these are showing up because of the freeways and the pesticide emissions. Here is the layer of all the environmental benefits. It was actually surprising that how little of that was already available, especially in terms of like city parks from the different cities. So that is something that actually some diligent work of students has put together, and gives us an idea of where environmental benefits are distributed. Again, more on the outlying areas. And if we're taking the environmental benefits index using the same methods to transpose that onto the census tracts, we also have a pattern emerging here. We see open spaces, we see the Vasona Park, we see the wetlands over here. Now, and Will already talked about that, all the different factors that are going into the social vulnerability, we can also map those by census tract, right? So this is data that's available from the census, and we can see at what pattern emerged there in terms of, for example, the poverty. We see darker values here. This is the Somos Mayfair area. Up here we're getting more to downtown. And this is, again, Gilroy, Morgan Hill here. We also have distribution of people that are linguistically isolated, maybe that are older, or that are older is here, or that are particularly young, and for that reason more vulnerable. People that have no high school education and possibly less of a voice, people that rent, and then people of color versus white populations. And we see that for each of one, a particular pattern is emerging, and we combine all of those in the social vulnerability index, And this is the combined map for that, and we see the color distribution being very similar to actually the environmental burdens, right? We see high social vulnerability down here in the Gilroy agricultural community. And remember, this was the area where we had a lot of the Superfund sites and dense network of freeways that were showing up relatively dark. And here we also have people that have high social vulnerability. So if we combine all of those three, right, the social vulnerability, the environmental benefits, and the environmental burdens, we arrive at these scores, the cumulative environmental index scores, which is our result that compares to what I showed you in the beginning for Los Angeles, right? So they arrived at these cumulative environmental index scores. So this is what we arrived at here for Santa Clara that takes all of these three components into account. So what this map tells you is where we have higher numbers and darker colors, we have high social vulnerability, we have high environmental burden, and relatively low environmental benefits. So these three things, play into the index. And we see again that especially this area here has relatively dark colors than all along those freeways and also down here in the Gilroy community. Now we can also look at, I apologize for the format here. This is output from a statistical program called SPSS, but hopefully I can just walk you through the results here real quick. So what we can do now is for each one of those census tracts, we can look at the score for social vulnerability and the score for environmental burden and the score for environmental benefit, and we can see if these are statistically correlated, if they have, if they have a mathematical relationship that is significant. Okay, and if we look at this graph here, we're looking at environmental burdens versus social vulnerability. So these are quintiles. So here are the people that have the lowest social vulnerability. Here are the people that have the highest social vulnerability. Right? So these scores are relatively high. These scores are relatively low. And here we have the environmental burdens. Low environmental burdens go along with low social vulnerability. Higher environmental burdens up here go along with higher social vulnerability. So that is the relationship that we found is statistically significant. These two, the environmental burdens versus the social vulnerability. The other ones, have not shown this statistically significant relationship. So the environmental benefits and the social vulnerability are not related in the same way that we have found, and it's something that we're still exploring as to why does it have to do something and how we have incorporated this factor, or is really the axis more evenly distributed to these environmental benefits. And then also environmental benefits and environmental burdens do not necessarily have a relationship with each other. Okay, so with this.
Thank you. Will and I actually were just doing the statistics on that was just 2 days ago, I think. So it's great to see it come together. I'm going to be talking about the discussion, and for me, I want to talk about three different parts: the environmental justice and inequality, and the strengths and limitations of our study, which we've already covered in dialogue, and then really, which I think is to open up for a larger dialogue with all of you about how could these results be used. And with Almaz, we've already started talking about some possibilities. I think that will be probably one of the most interesting parts. So environmental inequality, which many of you have seen, is essentially the extent to which there is a higher frequency and magnitude of exposures to environmental stressors in communities of color or low-income communities. And this is sort of a classic picture of kind of a low-income community, near probably some kind of, could be a coal-fired power plant. And this is the question that a lot of research around this area focuses on. And the flip is environmental justice, right? Essentially, environmental justice is the right of people to healthy, livable communities. And a lot of the environmental justice work, it's been around for now at least 30 years. And the early organizers, it's been a whole effort to sort of recover the history of environmental justice within the broader environmental movement. And a lot of the early organizers, and a lot of it, the early work on environmental justice was actually due to community activists pushing this agenda, people that were having high asthma rates in their community, living close to fixed pollution sources or freeways that were getting organized to lift their voice and make a change. Over time, the theoretical work has caught up to it and really kind of expanded. And so there's a pretty robust general theoretical framework that focuses on first the question of distributive justice, right? In this sense, is there equal access to environmental benefits regardless of race, class, sexual orientation, any kind of social difference, right? And is there equal protection from environmental hazards? Most of the research has focused on this equal protection from environmental hazards, and that's a lot of what we've been talking about. But when we were originally working on the sustainability and justice grant that got some of this started with Leslie Gray and Lisa Kelfler and other folks, I remember working and including this definition and thinking we need to also assess this question of environmental benefits. And part of that is how we ended up going down this path. The third dimension, the second kind of component of environmental justice is procedural justice. And this is that every community deserves a right to have a say in the environmental policies that affect their lives. And this is more difficult to study, and I think we don't get at it as directly as we could, but it's also something we want to talk about more in the future. Now, it's important to note that there are some critiques of sort of classic environmental justice activism. And maybe that's one of the reasons we started doing this work here, because I was postdoc in Berkeley for a couple years before coming here, and Rachel Morello-Frosch and some of our grad students and other folks, we've done some work together, and that's where I got inspired by their methods. And then we linked up with this amazing team that actually did it here and expanded upon it. And when you sort of look into literature of environmental justice organizing, there's a pretty strong critique that some of the earlier studies, or even some of the activist efforts, can really make a big sensation over a limited risk, right? So, maybe the F grade from the American Lung Association for 4 or 5 days that went over the state air quality standard, that's a pretty, you could say that's a pretty severe grade for for an important issue of air contamination. So there can be this over-sensationalizing of the problem. There can be this redirection of organizing efforts to a risk that might be a small risk compared to other risks that people are facing in their lives. And of course, the spatial scale of analysis can research the research outcomes. So when you look at national averages, sometimes it's difficult to determine if there are higher concentrations of pollution in lower income communities, right? But we took the county because that was I think one of the reasons we took the county because that's the legal unit in which we're embedded here. So we want to try to respond to this and also reflect critically on the strengths and weaknesses of the general cumulative impact approach, which we've been doing all the way through here. It's important to note that cumulative impacts, the idea is that there's some kind of combined effect, right? That it's not just, being exposed to hazardous waste from the freeway plus noise pollution from an airplane are just 1 plus 1. The idea, a lot of the cumulative effect idea is that there's a synergistic effect. And the truth is, we haven't really gotten to the point in these kinds of assessments with this kind of screening tool to assess these synergistic effects. But it does have a lot of strengths, as Iris covered really well in the beginning, right? It's an effective screening tool, integrates a lot of existing data sources, and it gets us down to the neighborhood scale. The weaknesses are that we don't model physical processes of pollutants and health exposures. We're not measuring direct health effects, as Will's mentioned before, and health research is still developing these more holistic assessments. What happens in the condition if there's high ozone concentrations and high particulate matter, right? They're doing some of these health studies that are coming out more and more, but the truth is we don't understand enough about these synergistic effects. And in terms of our specific study, I think the strengths that we've covered a bit is we include the freeways and the pesticides, one of the first studies in Santa Clara County. We also include environmental benefits. On the other hand, some of the indices are relative measures, right? It's important to keep that in mind. There is no physical modeling of the freeway, so the wind direction, for example, it's not playing a role in this. And there's also a lack of government monitoring stations. We spent a lot of time digging through with Will, looking for air quality data for Santa Clara County, and there's not that many monitoring stations, and it's incomplete in some years. The other thing to do is, what do we gain by adding in, we sort of ask ourselves, one of our research questions is, what do we gain by adding in the environmental benefits index? So we have our social benefits, our social vulnerability, and our social burdens. Then we overlay that with our environmental benefits index. What changes? And it's difficult when you see there's like over 375 census tracts in here, I believe. So how do you parse it out? A couple places that you can see, for example, in some cases, the presence of a big park, for example, Santa Teresa Park, which I think Will remembered in particular from his work in the capstone class, it did lower the cumulative index score in this census tract. In other cases, in some of the, if we look kind of north of the 280, it's possible that the lack of parks could be increasing the cumulative index score. So it's important to see, it does influence our overall cumulative impact score. The other thing that we want to look at going forward is, how do we measure social vulnerability? I remember part of this when Iris was getting started on this, she's emailed me and said, Chris, how do we measure social vulnerability, right? And I'm like, well, let me look at the geography literature and some of the sociology literature, and here are some of the main indicators. And that's what we ended up doing. We ended up following the general methods that are accepted. But there's different ways, and we ended up weighing each, and this is sort of what Virginia was bringing up, we weighed each of these indicators the same. We did a focus group in February, and we also asked them, what are the indicators for social vulnerability in Santa Clara County? They're community service leaders or some of the best known community service organizations in the county. They came up with this same list, but they also included social isolation, civic engagement, food costs, and crime. So those are some indicators we haven't talked about yet. And then they also, I said, okay, you have 100 points. How are you going to, which are the most important ones? And they said, they gave most important the poverty, dependent population, people of color, which is a tricky category, renters. So, we're going to play with there's the possibility of weighing these social vulnerability indicators according, particularly, possibly poverty, giving it a higher weight. Just a quote to keep us in mind here, when we talk about social vulnerability and all these things, and it plays into people's stereotypes sometimes. I think we also don't talk about other things like time to be engaged, and we talked about time poverty in this group, right? These are some qualitative measures that we probably have to get at through interviews and follow-up work. And also the possibility of turning around the whole focus on vulnerability to the assets that communities have, right? How do we build from assets and build from strengths? That's going to be difficult to get at, and it's not going to necessarily show up in census data, but maybe through an action research kind of collaborative. So what strategies could address an environmental inequality? These are some classic strategies that have been out there. I think the main one is fostering community-based action research partnerships, and Alma and I have been talking a little bit about what it would take to really build a partnership between universities and community-based institutions to address it. Addressing the underlying causes of inequality. This is a longer-term process. Some other folks have been working on this for a great deal of time. Investing more in pollution reduction, right? Particularly in targeting communities with higher concentrations of pollution. There's also sort of statewide initiatives sort of targeting environmental justice communities for new green job and redevelopment. So basically increasing jobs with clean industry. There's a whole kind of national, statewide effort in this area. This question of food access, and I think of the work that like Leslie Gray has done in the county. So these are some future directions. So in conclusion, we would say the areas along the 101 corridor and at the intersections of 680 and 101 have high cumulative impact scores and high social vulnerability. I think this is the 680 right here, right? And the inclusion of the environmental benefits index lowered the index scores in some areas with high concentrations of parks and raised it a little bit in other ones. And finally, yes, there are some indicators of environmental inequality based on the correlation between social vulnerability and the environmental burdens index in the county. That's part of what, to us, is kind of the conclusion and the beginning of the conversation is what we hope. Thank you very much.